the seismic force, we already see doubled deflection on these load cases, but it doesn't really matter. So we only want to evaluate how the building moves and what are the values of displacement only from the wind load combination, not seismic. Okay, seems to save some results. So we'll go now to results. Deactivate some the stories and go to deform structure, and now we can choose mass combination. And what we see here, the value is actually the period in hertz. So we will find the vibration period if we divide it 1 by this value. So basically I'll just amplify a bit. This is the first vibration mode of your building, which is good. It's the way it should. It should be general translation on the weak axis. So this is good as movement. So this is how this is the first mode of vibration, and we can see here that the building is properly connected. So it moves as one body, so it doesn't have flexible areas, and we can see that the deflection is on this area. So here it's a flexibility point.
Yes.
If you go in preview, we can see here some displacements, but their modes are dimensionless. Okay, we'll look at some other place for the vibration periods. Let's look into mode number 2. It should be translation on the long side. Okay, we have torsion in this case. It's not necessarily a problem. It is more relevant to see if everything is interconnected, so everything moves properly, or how we would expect for torsion.
Yes.
So it looks okay. It's a general torsion. And third mode should be translation on the long axis. It's still some torsion, but it's not necessarily a problem. We'll look also at the model participation factors to see how much of torsion. So we'll go to see more information to dynamics, eigenfrequencies, and go to preview. And here we'll see the period of your building, which is 3.56 seconds, which is not bad, as one approximation in Romania at least for buildings is 0.01 seconds multiplied by the number of stories. And if we think of the number of stories you have, so if we add this extra 2 to the 32, it's almost perfect. So it's a good period. This is only a quantitative assessment of the building, so it's not it's a qualitative and not a quantitative assessment. To get some numbers, we'll have to go to see here stories, story summary results, but we get only for seismic, so they're not that relevant. Let's choose directly the seismic on Y, but I don't think it's worth interstory drift. It's worth wasting time with these values, as the seismic force is quite small. Anyways, if I am to see the values, I will just select one member and then hit here refresh and see values not globally but per section, and they are really small even if seismic action is present. So here we can have some bigger values on X. I see we have bigger forces here. So these are some relative displacements, but they're not relevant for our study. So no, I wasn't, let's say, expecting this. So basically this is limited only to the seismic actions, but what we'll do is monitor some nodes. So we'll monitor, let's say, the corner nodes of a building. So for this I'll go to Z and pick, let's say, a column, and select it. Oh, okay, it was lagging. I want to select one column and monitor the node displacement for it, and I'll calculate in Excel the relative displacement. I think I need to find the column. Here we have columns. No, we have only, okay, there was no column there, that's why it didn't. So we'll go here. And here we'll, oh, but this ends. No, I need a column that goes from one side to another, or a wall, a structural vertical element that is situated somehow on the outer edge, because they have bigger displacement there, but it's continuous. This one is also discontinued, right? Or no? No. Or I think I'll just pick this center column. Okay, and I'll look for the nodes displacement. So I'll say displacement of nodes for the current selection from combinations. Why do you have so many combinations? I look through combinations, and let me look again. So you use automatic Eurocode combination, and what are these? Why do you have so many combinations? Because the computer generates automatic.
I need to check.
So the way you create a correct combination
Sometimes
is like this: Eurocode. Okay, let's say ULS equation 6.10, and you just have to add everything. That's all. And if you have the classes defined correctly, you will get the correct displacement. So this one envelopes the following combinations, which can be quite a few. I'm exporting them just for testing. So basically there are 704 combinations that are enveloped by this, because the program will establish whether you have those live loads at the same time, or you have wind on one side, wind on another. You don't need to create like this.
yeah.
So you did extra
Yes,
work
yes.
with this. So you don't need to think what actions can exist once. All the factors are generated from the
Yes.
Eurocode, and also the probability of coexistence of same load cases within a load group is determined by the load group properties. So for instance, for wind, which is exclusive, you will only have one type of wind in
Yes.
each linear combination. So okay, we'll just leave them exploded just for checking to see if they are generated correctly. and then we'll delete them and only use this envelope of combination for getting results.
Yes.
So I'll go to combinations. I'll leave this, I'll assume it's good, but I'll just test fast the load groups you use. So these are permanent load, it's no problem. However, in this area you chose domestic and they are standard, which means that all can be separate or together or not exist. They look good the way you place them. It's okay. So this is okay. Also on wind you have exclusive, so it should be okay. Now let's go to see the results. And I'll check the results from the combination I just created. So I'll go to displacement of nodes for current selection. And as a combination, I'll choose my combination, which includes all possibility of wind. And I'm interested in the side. Okay, I have to choose the nodes, not the column itself, the bar. And I will export this into Excel and check the values. We have now the values. So they are graphical, but also if we want tabled results, we'll go to preview. I don't know why it takes so much time. Maybe because of the fact there are so many combinations possible. And this pre-table, I will export it into Excel.
Yes.
So the problem is these exports are only absolute displacements, and also they're from different combinations. So basically I should use same combination to compare. So you see here, for instance, node 9 has 4 values as it has maximum and minimum. So I only have to pick one value per node. So it will be more complex. So basically I'll have to either use one absolute combination, or I have to pick up the maximum or minimum value of them per story or per node. Node 9, I can correlate it with this numbering, which can be activated here. So node 9 is at the bottom. For instance, for node 9, the maximum is 1.2 in the y direction. And actually, the y direction is the relevant one as it's on the, let's say, lower part of the building. So what I'll do is go through this application and start with the 1.2 value. The problem is with the next value, because the next value will be 4.1 minus 1.2. So it will be 4.1, which is an absolute value, minus the previous value. So it's 2.9. Of course, we can do in Excel something like this, but that's the main idea. So 4.1 should be extracted from the next. So for this level, we'll have 14.5 minus 4.1, which will result in 10.4. And then we go next. And we have here, I should calculate, so it is this one minus the value 21.2, so 0.2, I have 10.8. Well, if I start looking, so I defined only for the first 4 stories, I see I have this thick, which means it's okay. So it does a comparison between the target, which is 5 per thousand, against 2 per thousand I have here. So it's okay. But I have to take all these values. So we can either take them from Excel, or have to make somewhere, because if I take it from Excel, the problem is it gives me all 4 values per node, and I might be interested only in one value. So I'll do like this, minus, and evaluate floor by floor. 28.8. It's 7.6. It's already smaller, so it's no problem. Then I'll go, this was like this, 28.8 minus 36.9. So it's all about relative. This is why I have to calculate like this. This check is normally for seismic action. This is why it's implemented in SIA automatically for seismic action, but for wind, it's although it's not imposed, it's a good way of checking whether the cladding will be affected or not. So it's a conservative approach which will ensure the safety of the glass. So anyways, as far as I see, it's not affected. It seems that there's no problem. So if I look at the checks up until this floor, there is still no problem. So where I completed data, I see that everything is okay. But I'll go further. 46 minus 45.6.
Excuse me, if the result is not satisfied, so what solution to solve this?
What? Please tell me again. So this is, yes,
the result is not okay.
Yes.
So what solution to this?
Well, if the result is let's say the relative displacement is higher than the limit, then we need to make the building stronger for lateral forces. So in order to increase lateral capacity, we need to increase the size of elements. So we have to change the concrete size of the elements if they would have been not correct. Because reinforcement is something else. So the reinforcement doesn't influence this type of deflections. So basically that would have been the solution to So we'll go next. 54.8. No, the only my 9.2. So it's quite okay. but the disadvantage is that we don't get them automatically like we do for seismic action, so there's a bit of work involved here. No, 64.4 minus the lower side, 54.8, 9.6. Okay.
For this signal that can check
What?
to verify for displacement. Signal
Yes.
cannot check.
It's not integrated. This check is not yet integrated.
Can by menu or by hand.
Yes, we are in discussion of implementing this check into SIA, but it's not integrated. I would like to integrate it, but it's a bit of discussion with SIA, so SIA has to accept this and integrate my software within, so it will be automatic, the check. Otherwise, for the moment, this is what we have. So okay, let's see with this 17. It's a big difference, but I think this is an area where, yes, we have the building taller, you see, so it might not be a problem, 17.7, but it should have been in an area where we have it taller. I hope it's not a mistake here, because
6.4.
it's floor, the difference. Okay, we'll test it here. So it's for floor 11 where we have this big height. So I'll go straight to floor 11, but it's like
5 meter.
yes, but for floor 11 it's not correct, this value. It should have been taller, 4.6 I think. And if I go to 17.7, it's okay, because allowed is higher, so it's okay even on this floor. And then so I think there's an error within the heights, because here at 11 I should have had a bigger height. Then it's again 3.2, so I'll go with the difference.
92.5.
11.4, which is okay again. Yes, but here I think it's not 3. The difference is 3.2 as well. So there's an error here with the story height. They're not correct, the one we assessed. And see, here was 6.4, 3.2, and let's go further. So after we skip that tall part, I think here it was only, no, it's 3. Let me check the height, whether it was 3 or 3.2. 3.2. The other is 3.2 as well. So we have 11.6 again with the same value, and the next is quite the same height. So basically we'll test your building moves quite uniformly, so I don't expect any big surprises. There's only an error in this the way you inputted the story heights in Excel. They seem to be a problem there. 11.6 again. .7 and it's still okay. I hope there are not that many left. Where are we? Oh, okay, we're pretty. Let's check some that are. I believe they are okay. Let's check someone with bigger steps like this one on 5. So I'll check this one, which is 5 meter the height, and the displacement itself it's 333.9 minus 319.5. 14.4. This was here and it's okay. So with this it's actually no problem. Let's check this one, which is 4 meters. We'll input here 4 meters. And okay, 4 meters, and we have minus 11.5. It should be no problem. Okay, so basically everything is okay. So the 3.2 levels had no jump, though everything moved smoothly, and also the taller levels are okay. So this is saying the fact that everything is okay. So the maximum is 1.8. The maximum drift for whatever I inputted is 1.83 as a comparison with 5. So we have a lot of capacity. So it's no problem from lateral points of view. So the building has enough lateral capacity. I'll hit save here.